Now let's proceed with our subtopic lesson 3. We start with the cracking of alkanes. Now we said that since there is a low demand for long chain of carbons, we only need the likes of methane, propane in our daily basis and in several factors on several areas. We only need these three, not only three, but we only need all alkanes, starting with methane to decane. Any other alkane beyond 10, then that means we don't need it anymore. So for us to be able to obtain these three, either methane, either propane, either pentane, and all sorts, we need to have cracking of the long chain alkanes. So we have two methods of cracking. So we have thermal cracking. We also have catalytic cracking. These are the two major methods of cracking of the long chain alkanes. Now thermal means that heat. From the word thermal means heat, then high temperature also. Under high temperatures, the long chain alkanes breaks into shorter alkanes. We have catalytic cracking, whereby we use of catalyst. That is what we call catalytic cracking, the use of catalyst. Now, having understood that we only have these major methods of cracking of alkanes, we proceed now to our next subtopic. Our next subtopic is homologous series. What is homologous series? So we define homologous series in this way: group of compounds with similar chemical properties, remember it is similar, as the word we suggest, similar chemical properties, similar chemical formulae, and they exhibit a steady gradual change in physical properties. And they exhibit a steady gradual change in physical properties. So these members, it's gradually, so means slowly. They have similar chemical properties with the similar chemical formulae, and they exhibit a steady gradual change in physical. A steady meaning not rushing or not a faster rate, but steady, at a standstill, right? At a standstill. That was called steady gradual change. Now let's talk about similar chemical formulae. So if we take alkanes let's discuss its homologous series, because alkanes have homologous series. All of them, they exhibit a similar chemical formulae. So let's see it. We say the chemical formula is C. That's the formula of alkanes. So methane is our number one. So where n we said is an integer, n could be 1, could be 2, could be 3, could be 4, but not a decimal point. As we stated, n is our integer, but not a decimal point. The integers are non-fractions, nor are neither are fractions and nor are decimal points, right? So if our number one component, all that's found in alkanes is methane, it's number one, so we will say YH like that, 2 times 1, right? And then plus 2. So methane is written as CH4. Downward, let's pick ethane. C and H2N plus 2. So N is 2, H, right? Our 2 times N. We've said we are picking ethane, so number 2. 2 times 2 plus 2. So that is C2H6. So these are subscript 2, 6. Those are what you call the integers. They are non-decimals. So that's a good example of homologous series. If we take alkenes. Also, alkenes and alkynes are homologous series in their own. They have a certain chemical formulae. Let's look at it. Alkenes have CN H2N, right? And then if we alkenes, remember that alkenes, we don't start with methane. We don't have methane. Our number one element or our number one component and alkene is ethene. So since ethene is our number one, it begins with the C and H2 like that. And then alkyne in that order. So those are examples of homologous series. Homologous series. Hope that whoever is capturing this notes have captured something, or you may take a screenshot over the same for the next preview. For the next preview, we proceed with another definition, which is isomerism. 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 We also always say that is the existence of compounds with same molecular structure but different structural formula. So what does it mean that they exist with the same molecular formula with different structural formula? If we take an example of pentane. Pentane can be written in several ways if opened in its structural way. We have condensed. Remember that we have the condensed mode and structural mode. So for instance, we take pentane, whereby if we take pentane carbon, there are 5 carbons like this, with hydrogen bonded in each of it. Hydrogen, hydrogen. That's our original pentane. So this pentane can be made in many ways, but with our back something in mind that the parent name will remain to be pentane, but other things will be changing. Like if I decide to put one carbon and branch it here, the name will change a bit, but the thing is that we have opened many different structural formula of pentane. So carbon, carbon, carbon. Let's say we now drop it at this point. Carbon, carbon, remember to be separating these dashes, they don't directly intersect, right? Now you see the parent name will remain to be pentane, because the carbon chain that we have here are 5. But now, since we have branched this carbon to this element, we will count the longest chain. So the name will change a little bit, but not really that much. But we will now count this carbon 1, 2, 3, 4, butane. That's the longest carbon chain that we have there. 4. Then while naming, we'll also consider this. Where is that alkyl part? Where is the alkyl part placed? It's here. If we suppose we say this carbon is number 1, this number 2, this number 3, this number 4, we'll name from starting with this direction. 1, hope you are seeing it. 1, 2. So it's under 2 methyl. These are methyl and also butane here. 2 methyl butane. 2 methyl butane. So the name have just changed a bit, but what we know, it was initially pentane. So that's what is called isomerism. Now from here it derives as to something called isomers. That's another thing. Now these compounds here are what we call isomers. Isomers are these compounds that we directly see there. Those are what we call isomers. Call isomers. 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 Compounds, we'll define it as compounds with same molecular formula but different structural formula. Now these are the we cannot say that how do we call it, methane is not an isomer. Reason being, we only have some few elements. Let's say the exception of methane and ethane. So our methane is only CH4 and our ethane is only C2H6. Suppose that we want to open it. Let's try this. Carbon, carbon, carbon like that, and carbon like this. So there is no way you can branch this, so it can't have any other compound related to it. Pentane had a compound here related to it, but now this one can never have. We don't have any other carbon present in it. We also have this carbon. So we can't branch this carbon to this part because it cannot. In fact, it can't. So we only have under alkanes. We have as from we have pentane, hexane onwards. We don't have the isomers of methane nor ethane. That is clear. You can just even underline it. It's a very keyword. We don't have any isomers related to methane nor ethane. Methane have only one carbon and ethane have only two carbons. So this one cannot branch. It remains like that. But pentane and the rest have several carbons, so they can branch, forming different naming. And from here now we move to naming of the naming of alkanes, which is the nomenclature of alkanes. Now we want to discuss on how we derive the names of this one. Once it has branched like this, it forms an alkyl part. So we could be having a methyl part once it has branched, or ethyl part, or a propyl part. So those are the alkyl groups. Those are the alkyl groups that we have. Once it has branched, it can either form a methyl, ethyl, or propyl. So let's proceed. So we want, okay, there's something I had said before earlier, alkyl group do form methyl, do form ethyl, do form propyl. Now ethyl, let's begin with ethyl, no, methyl, sorry. So it, the formula is like this. It originates from methane, then ethyl C2H5 originate from ethane, then we have propyl C3H7 originate from propane. These are the basic alkyl group that will enable us in naming of the alkanes. Now we proceed with the naming of alkanes. Now. It's clear that we have this in advance, alkyl part, because it is the basic thing that most of the learners do confuse to understand where is ethyl, where is methyl, and where is propyl, where do you place it, and where is it being placed. So let's enter into the deepest of it so that you can be able to understand something there. We will see a case example for methyl and methyl, also propyl. Nomenclature of alkanes. Nomenclature of alkanes. Nomenclature of alkanes. So there are several rules that do guide us to while naming these alkanes nomenclature. We have this prefix that we do use and suffix. Let's take now case example, butane. Someone tells you draw. How do we name? Draw and naming. So butane, let's start with butane. We have a condensed formula first before we proceed to our open formula. So butane is carbon number 1, 2, 3, 4. So here we have hydrogen. Those are the 4 hydrogen of butane. Butane is our number 4. So if suppose we want to include it, that one becomes open structural formula of butane. Condensed, can write it here, open. Condensed, we can pick carbon, then hydrogen, ziko tatu, right? So we can see hydrogen here 3, also here 2, right, like that. So we always count this one, 1, 2, 3. Carbon, hydrogen 2, carbon, hydrogen 2 in the middle. So the last one, carbon, hydrogen 3. Remember not to exceed anything. 1, 2, 3, 4. 1, 2, 3, 4. And then hydrogen should retain the way you counted them there. So this is an open and this is condensed. Right? That's open and this one is condensed. Hoping that we are together, all of us. Open and condensed structural. Now we want to name a certain compound here so that we see if we are able to get into the deepest of methyl, ethyl, and propyl. So let me begin with methyl. Let's name now one element, one compound here with hydrogen. Let's pick that example. We have al3, carbon here, carbon, hydrogen al2, we have carbon, hydrogen al3, carbon, hydrogen 2, carbon, hydrogen, and then carbon, hydrogen 3, carbon, hydrogen 3. Remember that carbon at all times, remember, it uses all the 4 valence electrons. So for instance, this case, carbon will bond with the 3 hydrogens plus this dash here. This dash represents the bonding between carbon to carbon. Also this one, carbon to carbon, those are 2, plus this hydrogen 2, those are 3. We also have here like that. So carbon will always bond with the 4 valence electrons, 4 strong covalent bonds. Now, how do we name it? We have now an alkyl part, which is this one. It's methyl. How do we name it? How do we name this a compound? A. How do we name that case? How do we name it? So we have carbon, hydrogen in that manner. So how do we name this? We want to look at it now. Now, this alkyl part is in the carbon number 2 if we consider this carbon as our number 1. Also, we consider this our number 2, this our number 3 and number 4. So this carbon is our this alkyl part, which is methyl, is our number 2. So we shall read it as 2. It's a number 2. We have already identified as being methyl dash like that. Call it a dash here between a number and a letter. We call it a dash. Methyl 2 methyl butane 2 methyl butane. Why methyl butane? Now in naming, there of nomenclature naming of alkanes, there